Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Madam Shana. We from Group 5 Tutorial 2, consisting of Akila and Hazika Mikael and me Masnur, going to present our project on PBL mathematics on statistics. So for today's project, we going to present our analyzation on principal labor force trends in three states in Malaysia, which is Johor, Kedah, and Kelantan, which is our data is obtained from Department of Statistic Malaysia (DOSM), and from there we collected at least 15 year of data from 2000 and onwards, with year being the independent variable and principal level, which means the number of person as the dependent variable. Our aim on this project is to compare employment patterns across the three states by using frequency tables, graph, and summary statistics and data that we obtain by using SPSS software. By doing so, we hope to get better understanding on the differences in labor force dynamics between the states and what they might signify in real world economic and social context. So our chosen data, as I just mentioned, is the annual principal labor force by education attainment statistic for these three states. So as you can see, we provided the data for each year for the employed person by educational attainment in Johor from 2000 and 2014 for each state actually. So this is the Johor part. We have actually 15 data for 15 years, and also this is our frequency distribution table. So we provided this table for each step. So basically, a frequency distribution table display the frequency of each data set in an organized way. It actually helps us to find patterns in data. So and also enable us to analyze the data using measures of central tendency and variance. And our first step that we need is to collect the data, so to organize it in a form of frequency distribution table. After we get the data, then we can proceed the calculation and statistical test in the SPSS software. So this is our data containing class interval, frequency, cumulative frequency, upper and lower boundary, class width, and also class mark. Uh, this is for Kedah. This is the frequency distribution table. This is for Kelantan parts. All have 15, at least 15 sets of data. So this is our attempt on SPSS software to do a calculation and obtain required data, required statistics, such as we gain our frequency distribution table by the help of SPSS software. And as you can see, how we managed to do a calculation by using this software, we managed to get the mean, uh, the standard deviation error, and also the statistic. Also, we get the median, variance, standard deviation, minimum and maximum value, range, interval range, skewness, and all the important data that we need for for our analyzation on this project. So we can see that how each state's having their own data from SPSS software. So as you can see, we also do again a box plot, or we can also call box and whisker plot, which is this box plot visually show the distribution of numerical data and skewness by displaying data quartiles, or also we can call percentiles, and also averages. These boxes, each box represent the interquartile range IQR, which indicates where the middle 50% of data points fall. So as you can see, we managed to obtain three box and whisker plot for each state. Later on, we will compare between two states, box and whisker plot. Okay. As you can see, after that, we also obtain histogram, which is this histogram are particularly useful for our understanding on the shape of data distribution. This histogram, wait a minute. Yes, this histogram graphically shows how frequently every value in dataset occurs in relatively objective way. Histogram actually makes easy for us to see which values are most common and which values are at least common. In histogram, type of data being measured is represented on horizontal axis, and vertical axis represent how many observations are in each bin, we call it, or bar. And other than that, we also obtain ogive, which is ogive is a graphical representation of cumulative frequency distribution, and we call it as ogive, or someone calls cumulative frequency curve, which was this essentially a line graph actually that drawn on maybe graph paper, but we use the SPSS to do so by plotting the actual lower or upper limits of the class intervals on the x-axis and respective cumulative frequency of this class interval on the y-axis. So we obtain our data to show the pattern, how the trend goes from year to year. Yes, and as you can see, other than this ogive, we also gain another type of graph that can be drawn to represent the same set of data, like histogram, but we call this as frequency polygon. By taking the median, we managed to do this graph. A frequency polygon constructed by using line to join medians, midpoints of each interval or bin or bar. The heights of points represent the frequency. A frequency polygon can be created from histogram or maybe calculating the midpoints of bins from the distribution table. Okay, moving on to our next part, which is comparing the two box and whisker plot, which is by using a special software, we obtain the employed person educational attainment in Kedah and Kelantan. So to compare these both, we can see at the Kedah, the left one, it shows a higher median, and possibly a wider range of employment based on educational attainment compared to Kelantan. While we can look at Kelantan, where it have lower median and possibly narrower range, indicating less educational attainment among employed person. On the whisker part, actually the whisker is the extent from edges of box to the smallest and largest value within 1.5 times the IQR. And the outlier is any points beyond whisker considered outliers, which may indicate exceptional cases in employment based on education. So we can compare that on the median. On the median, Kedah likely has a median around 700. Yes, and Kelantan median appears to be lower, indicating potential differences in educational attainment. On the variability aspects, we can see that the spread of data in Kedah suggests there may be a wider range of educational qualifications and employment opportunities compared to Kelantan. So, box and whisker plot illustrate a comparative analysis of employment based on educational attainment for two regions. It's highlight the difference in median figures. So on our discussion, so we discuss and conclude our analysis on the graph, the tree graph that we present about the statistical analysis reveals differing employment pattern across these three states between 2000 and 2014. In terms of distributed shape, Johor employment data exhibit a positive skew, right skew where it goes to the right, and indicating a concentration of lower employment values in early years and stretching towards higher value in later years. This skewness literally reflects rapid growth during later part of period, driven by major development initiatives such as Iskandar Malaysia, which spurred industrial, infrastructure, and economic expansion. In contrast to the other two, it show more symmetrical and steady trends with moderate increase in employment suggesting relatively stable economic activity with few abrupt changes. The lower variability in this state supported the narrower IQR and lower standard deviation reflects less industrial and slower urban growth. There's maybe several real world factors such as urbanization and infrastructure, where Johor being part of Southern Economic Corridor and neighboring Singapore benefit from better infrastructure and foreign investment. In education and skill training, maybe there's higher education access and vocational training in Johor, leading to higher and more dynamic labor market population. And Kedah and Kelantan have more rural population and facing challenges in workforce. In conclusion, the analysis highlights how asymmetry and employment trends reflects the unequal pace of economic development across Malaysian states. Understanding such patterns help policymakers target resources more effectively. And I think that's all from us. Thank you very much.